Sigh. This is what I get for updating to Windows 8.1. Thanks a bunch Microsoft. Angry face. Sorry about this fellow students. This almost never happens, but ever since the overhauling Windows 8.1 update things have gone down the hill into oblivion. Hang in there while I try to fix the damage.
One eternity later.
Well, I have managed to fix it just enough to where it will play again. Okay, so folks, in this here question Channing will explain the fracking process in steps/parts. The process of hydraulic fracking involves first identifying the location where a shale formation is and going all eminent domain on landowners if needed. The next step involves drilling a hole a mile down below all freshwater aquifers and groundwater sources. As an environmentally minded precaution, the upper portion of the drill head is drilled with a water-based mud system, which protects aquifers/groundwater sources, while simultaneously cooling the drill bit. Once the drill drills a hole well below freshwater aquifers and groundwater, a steel pipe called a casing is inserted, and cement is added to the walls of the casings outside, creating a barrier in order to prevent leakage into the surroundings. Then the drilling is continued, this time at an angle, until it becomes horizontal. This part is known as the kickoff point. This horizontal drilling can continue for up to 2 miles, or maybe longer if needed, depending on the location. Once the desired depth has been achieved, more protected casing and cement is added, and then the drilling rig is removed in order to begin the next step, which is known as completion, where the water/sand and the toxic cocktail of chemicals the industry lied to you about is injected, and the gas is removed. Okay, so people, continuing where our last left off. Completion begins with the installation of a completion valve that pumps water and gel into the gas tube in order to clean it out before perforation. Perforation begins with perforating guns being lowered into the tube and into the shale formation, which then fire 30-inch long tunnels that are 1/3 in diameter, known as perf tunnels. The guns are removed in order to begin the actual fracking. The industry brings in a fleet of trucks capable of 40,000 horsepower that are used to blast the shale rock with water, sand, and a cocktail of deadly chemicals at high pressure. This causes the perf tunnels to break out into the rock, forming fissures in the ground. The water and chemicals is used to break the rock apart, while the sand helps to keep the fissures open. These fractures typically are 200 to 400 feet in size. This process releases the natural gas into the passages. After the liquid used is pumped away, a plug is inserted to keep the gas from flowing out at the wrong time. Next, another perforating gun, controlled by an electric line, is inserted to do the same process mentioned earlier in another spot along the horizontal tunnel. This process is repeated all along the horizontal portion of the drilled out tube in the shale formation to extract as much natural gas as possible. Each process of fracking and plugging that is repeated is referred to as a stage interval. After completing all the stage intervals of fracturing, the worker rig is installed to remove the plugs via the well bore, which allows the natural gas to flow out through the gas tube. A wellhead, or termed a Christmas tree by the industry, is installed at the surface to capture the gas flowing out, where the sales/storage process begins. As one would probably imagine, the process I explained earlier does not come without its voodoo hexes, and in this case, it's the pollution byproducts that many pro-frackers will sadly attempt to justify. The main concern with fracking is that the chemicals used in the process have a chance of seeping into the groundwater. The gas tube leaking combined with the casing being inadequately applied can result in the hydraulic fluid leaking into the surrounding groundwater, thereby polluting it. Methane, a byproduct of the extraction process, may also contaminate surrounding aquifers and groundwater when the tubing is removed with the well bore. The same methane also exacerbates the effects of climate change. In addition, some of the chemicals used in the fracking process are not recovered, with about 30–40% or even more being left behind. What makes this problem even more sinister is that the industries do not have to disclose what they are using to the public. Federal Energy Policy of 2005 exempts all of the industry from regulation. Because somehow pro-frackers believe that cheap energy beats water that is contaminated with benzene and potentially ethanol along with many other toxins, many that have already been deemed carcinogenic. Figure 1 simply shows the distribution of active and non-active fracking sites throughout New York. It was used to graph methane concentrations vs distance to the nearest gas well. In figure 3, there is plenty of evidence that the closer a drinking water sample is to an active fracking well, the higher the methane contamination is. There also happens to be more active sites that are labeled as a hazard needing mitigation as shown by this shaded section here, at least compared to non-active sites, where the gas has all been extracted already. The latter relationship would also be affected by the depth/extent of vertical/horizontal drilling at that site, which is not taken into account in the data as it says here, but which would affect the methane levels, and whether the pipes potentially leak directly into a groundwater/aquifer source. In general, active sites that were closer to the drinking water samples showed higher levels of contamination when compared to non-active sites farther away, and even the non-active sites that were closer still showed lower levels of contamination altogether. In Table 1, the data from both active and non-active gas wells are shown. The data shows the direct relationship that the active sites such as Catskills and Lock Haven possess higher methane, CH4, levels expressed as a higher mean and standard deviation number, whereas the non-active sites have smaller amounts of methane levels, but higher amounts of carbon-13 isotopes. Non-active Genesee and Catskill wells have higher amounts of C13 and methane contamination levels, which are overall lower. As for the C13 results from active and non-active sites, as I mentioned earlier, the non-active wells have a higher C13 value than the active ones. In accordance with what is explained in the data, the total active sites have methane contamination that was thermogenically created. This comes from the hydrocarbon layers to extract the hydrocarbons from the shale rock, thus indicating the methane being there as a result of hydraulic fracturing. From where the methane came from, it can be concluded also that sites like these, including the active Lock Haven, Genesee, and Catskill, are all closer in proximity to groundwater sources that were subsequently contaminated. Some of the non-active sites showed signs of methane contamination that came from shallow microbial activity, biogenical creation, in the soil. This is due to the total number being more negative than -64 in accordance with the data, as well as the lack of drilling to stir up the methane within the hydrocarbon layer. In addition, one can conclude from some of the non-active sites like Genesee that have a standard deviation less negative than -64 that the drilling has only stopped very recently. Also, biogenically created methane in the water would indicate that the fracturing site is farther away from a water source. Yes, it is true that the scientists can rule out water contamination from brine sources in the Appalachian Basin. For one, there is no large amount of brine that naturally occurs in the Appalachian Basin, and the values specified on the chart are too large to match any of the data from the collected water samples. I mean, come on, is 87, 25, and 22, even when added to the standard deviation, remotely close in value to 33,000 plus minus 11,000. However, they cannot rule out fracking as another reason for groundwater being contaminated. Since data shows very well that many of the places like Catskill and Lock Haven all have contamination that stems from either methane or saline solutions used in the hydraulic fracturing process. Now, to clear some confusion on people's minds, saline solution by itself is not the same thing as brine. For brine is, more specifically, salt water with a high concentration of salt. With regards to reading Z data, do you see this number of 87? And tell me, is 87 less than 100? That's what I thought. Thus we can conclude that the water samples at Lock Haven Formation do contain methane-rich gas. This is all in accordance with the parameter instructions specified on the top. Active Lock Haven Formation showed large amounts of methane-rich gas sitting in the water. Don't forget that methane is insoluble, whereas Active Catskill Formation was a mixture of both saline solutions and methane that contaminated the groundwater. An active Genesee couldn't be fully determined because no background data was given, although from table 1 it is clear to see that there is methane gas present in the water. So overall, in conclusion, one can say that the groundwater was contaminated as a result of hydraulic fracturing. After all kinds of fossil fuel extraction processes make environmental stewardship and safety look like Channing's winter track season non-existent.